Hello, everyone. Welcome to COEX Talk. Today I have two very special friends of mine, and also they were my classmates when we were doing our master's in environmental building design at the University of Pennsylvania. We have Shibei and Michaela Singson. So I'll let you guys introduce yourself. So maybe Shibis, we can start with you. Tell us a little bit more about where you're from, what are you currently working on, and your passions towards environmental design.
Hey, I'm Shibei. I'm from China. I went to school with Maria Mika here, and I'm passionate about sustainable design because I didn't grow up with those. I know it's the right thing to do, but I don't see it in my childhood, so I want to become an architect who can do the right things. I guess right now I'm an enclosure consultant, more in a consulting business in architecture side, and try to get people to design high performance buildings.
That's great.
Yeah.
Mika?
Hi, I'm Mika. I'm from Manila. Right now, I'm doing environmental or sustainable this like I don't know if it's sustainable design. Basically, I'm working with an architectural firm, and I'm working with a sustainability team. Um, and we try as much as possible to make sure that the design adapts to the climate. One of the reasons I really like um, doing this is because I feel like there are a lot of problems that need to be solved, and I feel like a lot of them can be solved by um, really thinking about the climate and really finding solutions in, like, I guess, solutions by adapting to the climate. Like, Maria knows this, like, that there are a lot of environmental problems that I have issues with in Manila. There are a lot of things I would love to solve, but as of now, I feel like I'm still learning, and that's why I'm still working here to try to find more solutions for the things I want to fix in Manila.
So, quick question for both of you. In your terms, not like the professional definition of sustainable architecture, but to you guys, what is sustainable architecture? What does it mean?
What does it mean? I'd say it means structures that don't destroy the land that it's built on, or structures that don't destroy anything in general. Like, as much as possible, structures that can, like, possibly, if they can, like, give back as well, like, to the land that it's built on. Yeah, to me, that's sustainable architecture.
So maybe Shive, you can answer this question for me.
Yeah.
To design a sustainable building, when you're designing it, what are the factors that you think about when you're designing? Like, what should you, because in normal architecture we think about the form, we think about the shape, and in terms of sustainability, you're not only dealing with your client, you're dealing with a lot of different surroundings, surrounding elements. So what are these to you as a sustainable designer? And every designer is different, but to you, like, what's important when you're designing? As Mika said, climate is one of them, but what else is important to acknowledge when you're designing?
Yeah, well, I feel like architecture is so complicated, but the first two criteria I look at is carbon footprint. So how much carbon is it emitting by building this building? Everything people do emit carbon. So if you consume electricity, if the electricity is produced with a coal plant, or it burns fossil fuel, it it emit carbon and is harmful for our environment. So if a building is so consuming that it used so much concrete, it used so much steel, um, it will have a lot of embodied carbon. And if the building's not well designed, is not well insulated, it might consume a lot of energy when it's in use. So mostly in the air conditioning and other electricity consumption. And if the building's not well designed to last longer, then you have to put in money and effort and material to fix it. And that also is a waste of energy and a waste of carbon emissions that add up to other environmental polluting things that produce material for buildings. So I want to see in sustainable architecture as something that we design carefully to reduce our footprint to the environment.
So let me ask you another question. Why do you guys think that this is a very important topic? And I have my own answers, but I'll let you guys answer. Why
do we think it's important?
Is it important that we all talk about this? That we all start paying attention to the buildings that we're living in, that we're designing, that we're building? Because it's not only the architect and the builder, it's also the user, as we learned in school. Like the user has the capacity to work with its building to become more sustainable. So why do you think that this matters?
I think in general, like it's just important because Shibei was talking about like carbon footprint, like, and in general, buildings take up, I think, about 30% of carbon emissions, like of all carbon emissions. And so it tells you how big of a scope or how big of a difference it can make if we can reduce carbon footprint or create more sustainable buildings. And Maria, you mentioned that it's not just the architects and the like engineers who are in charge of like reducing the carbon footprint. It's also the users, because it's up to the users to, like, I guess, turn off lights when they're not needed, and like reduce appliances, like stop buying appliances that you don't need, or I don't know, just in general, like if we were all more efficient, then we'd all help reduce energy consumption and carbon footprint. So I think it's important for people to know that they can do their part as well. I don't know if that's something that architects in general are able to impart to everyone. But yeah, they can, like in terms of usage, like the person living in the space or working in the space can make such a big difference by how they operate in that space.
Well, I guess on top of Mika's opinions, a very simple example is a house in desert climate. So in a very hot day in desert, usually you have a pretty cool night. Am I right?
You're very right.
Yeah, so if you have an office and you have the opportunity to open the doors and windows at night, assuming there is no burglar in your neighborhood, you can actually flush the air interior to the night coolness outside. And then you can close the envelope again during the day and use that cool to sustain during the day. So it ensures you have fresh air intake and also lower your air conditioning load for the hot day. So that's a that's a owner behavior that Miko's talking about, but architect can do so much to make that a lot easier for you. For example, they can insulate the roof very well. You two collaborate on a project at Penn in desert climate. You probably know better about this, but design can do so much. Design can provide thermal mass and make your interior temperature stable. It can insulate it well to reject heat from your interior. It can make people's lives so much more comfortable and easier. But in previous architecture design practice and education, people put so much more emphasis on visual effects and cool things, design as conceptual thinking and poetic expression, and they forgot about the basic thing about human comfort, and they forgot about environmental impact and the practical, boring, but also necessary things.
To add to Mika and what you were saying, Shibis, it's like our ancestors knew how to build and they knew why they built it, and these practices are old. They're not like sustainable architecture is not new. It's not something that we just came up with because of climate change. It's like before, when people understood the planet better and the environment better because they didn't have advanced technology, they were trying to survive to or adapt to their climate and their region. So they developed these things. So a lot of the things that we learned at school, it's like old, like thermal mass is not a new thing.
No.
The
People live in caves 1,000 years ago.
Yeah.
Caves are thermal mass.
Yeah, exactly. Or more local and regional materials. Those materials were made and were placed there because nature itself gives you what it needs for you to survive. So it'll give you the materials that you need. So in the climate, in the desert climate, adobe is such a great material because it's a really good thermal mass and insulator and all these properties that adapt to its climate. So if you go to tropical climates where you can build off of bamboo, it's a good material for those climates. So yes, I don't want to take away from your conversation. I just wanted to add a little bit more to it. And also wanted to say, like, to me, it's important that we talk more about it, and not only architects and people in the profession, but there's 7 billion people living in buildings. So that's the most important thing about sustainable architecture and sustainable practices, because I don't know how these 7 billion people live in their conditions, but that's a lot. So just starting from there, it's already overwhelming, and we can do a change and an impact. So Mika or Shubis, is there anything you want to guys add to this conversation? I think you guys are going to show a little bit of our project when we were at Penn.
Yeah, sure.
But I don't know if you want to add to it. Miki, do you want to add something?
Well, in terms of materials, I definitely think there's something about materials in that locality. Like I used to work with this NGO also that did they were trying to develop like bamboo framework for houses. And the cool thing about it is bamboo is everywhere in the Philippines. Like it's so easy to get, but it's not really being used in construction. But the reason that they were developing it is because it's actually like bamboo is really flexible and it can be strong as well. It's pretty flexible in terms of like earthquake resistance, and that's something that happens a lot in Manila as well. Like there are a lot of faults that cause earthquakes. So what's interesting is the material that works for construction, or like the flexible material against like earthquakes, is right there. but we were using something else. Like we were using concrete, which is high in carbon, and um, something that is like more synthetic. Whereas like bamboo, which grows everywhere and like can be used easily, was not being used, and it's only now that people are starting to look at what's around, or what it's just interesting because it's like it was right there, but we didn't think about it until now.
Yeah.
So it's interesting to see like where sustainable like architecture will take us. Like who knows, like maybe in the future everyone will be using materials that are available like where they live. It's also interesting because in terms of transportation, you'll need less of transportation for to get the materials onto site if it's just around the corner. So yeah.
And you can replace it easier and faster because it's there and available.
Yeah. So
that was great. So we're gonna show you, Shibei, you want to share your screen? We're gonna show you what this sustainable architecture looks like on a research studio that we did on our masters.
Well, I think our studio was a little special because we were also looking at water, and that's a very important component of sustainability where people usually ignore. And like what I said, that most of the people in the sustainable architecture industry thinks like me, that carbon, but actually water is getting so scarce and we need to think about that. So you guys can start about and tell me where to look at.
So I'm gonna say briefly, our project was to analyze a mobile home in 2 different climates and extreme weather. So one of them was Buffalo, New York, and the other one was Houston, because hot and humid and cold and humid are like amongst the most difficult climates to design on. We had to select either or and do some analysis for it. And we decided to do a house that we called the watershed because we wanted to think about real watersheds and what they do when they like absorb the water, filter the water, and like as a natural system. So we wanted to kind of like display with our house that portion of education, like, oh, watersheds are a thing that are in danger right now in a lot of different places. And so because it's Houston, it's also near the coast. So we had to do a diagram of the systems that we were incorporating in this little house. So Mika, you wanna, this is an emergy diagram. So I don't know how to describe an emergy diagrams. But.
I'm gonna add also that the reason we wanted to look at water is because there's a lot of drought happening now. And we feel that water is such an important resource. And if we could take architecture as a means to preserve that resource, or like make it more available for people, then that would be amazing. So this is just a basic emergy diagram that we created for the entire house. By emergy diagram, we mean like it takes into consideration all the systems that would be placed into the house and all the resources that you would need. And as much as possible, the reason why we create these diagrams is as much as possible, we want it to be a cyclical diagram where you don't have as much wastage, or you don't have as much resources that are getting wasted. So
go ahead.
So what we tried to do was basically create a mobile home that could capture rainwater and be used within the house. Apart from that, we wanted to use that water as a means of heating and cooling the house as well. Pretty much, yes. Shibei, do you have
And
anything
then
else to add?
the other thing is that the idea with the mobile house is that because a lot of places will be affected by sea level rise and hurricanes, you want to make sure that you can move your house to a less threatened area in case of a hazard. So it's kind of like a building a resilient place to live.
Yeah, because right now we're relying so much on grid provided by municipalities.
Mhm.
So if one day those things are not stable anymore, you would like to have some individual control over the necessary resource in your life. For example, electricity and water.
Yeah. So we had to look at transportation and the unit configuration because one unit accommodates about 1 to 3 people. It's a tiny house. So we needed to provide for bigger families because not all families, I mean, you can only accommodate so many people. So you want to make sure that this can grow depending on your family size. So we designed this like module and this component to the module where you can connect other houses if you needed more rooms. So what you see here is like the um, one unit 3-person connection, and then how it can grow depending on your family size. Um, on this like on this we had to do the oh, so this is just a diagram showing all the systems that it's like our wish list, like what do we want to put in there. And it was like all the techniques that we wanted to incorporate, environmental techniques that we wanted to incorporate. So some of them are like vegetated roof, the stacked ventilation effects, or looking at orientations in the systems, and then have operable windows, reclaimed materials, elevated on piles. And then at a very early stage, we analyzed what the energy consumption of the house would be like with its appliances and its embodied energy. So that comes from the materials. But this was just like preliminary. We later on tested it and did the analysis of it. So you can go to the next slide. So this is the site. We had to pick a site that was in near the downtown area. So we did the study of the wind, the sun angle. We did the site density, how many houses fit into the site, because the more density you can have a place, the more efficient is at the end. You're using less land per module, which is like a better scenario than just having a small building in a big lot. You're eating less of the land. We did water and flood prevention techniques. We did ecology and resiliency because this is an empty lot. There's nothing in there. So we were strategizing how we were going to get vegetation and species in it and become a more like an ecosystem, not just like a house with its systems, but at a site level, at a bigger scale. How are these houses working together? And then, yeah, we created a diagram showing how we were going to deal with radiation and have a site cooling effect so that the site cools down before we have to cool down the houses. So it was just thinking about this whole concept of the house and its systems at a bigger scale, and then the use of vegetation to cool down the site and provide enough shade for the houses to be below the tree canopy, because it creates a cooling effect. So if you cool down the site, the less energy you need to cool down the house. So you can go to the next. It's a lot of information.
Yeah, we did so much stuff.
So yeah.
So look at the watershed sections, and you can see different components we mentioned previously in these sections about filtering water from a vegetated roof, and also different layers of sand, stone, sand, charcoal, and UV, and to get rid of bacterias, and um, to bring it down to a level that human can use them. In the house, we prepare tanks for people to store the water, and also a panel for evaporative cooling to control the temperature of the water. I think we also have a composting toilet that can also, to some degree, regulate the temperature for the interior in the winter. We did some study on the local plants and on the assembly of the roof itself, and see the thermal property and moisture property of them. Basically looking at the different component of the building and make sure that they work together. So, and we take a closer look at the transportation and water consumptions. Maria, do you want to talk about those?
Yeah, so what we did on the transportation impact diagram here and analysis is looking at which places, so transporting the unit from one place to another in case of a hurricane, how much efficiency and energy will it take up? So that's pretty much that, those two analysis. And then on the water consumption, we calculated what the average of water consumption in a regular house, which is 93 gallons per day, I think, per person. We brought that down to 33 because we removed the water toilet, we used energy efficient faucets, and what else? I can't remember what else. And so, and then we actually incorporated the user here. Like if it's a more conscious user, then the water goes down even more. And then we did a life cycle analysis, and that measures the carbon emissions from the materials. So after that, after all that analysis,
oh, I forgot where the life cycle. Oh, yeah, right.
it's just
Sorry.
a diagram showing like different scenarios of, if you use this material, then your carbon emissions for your house are going to be this high. So because we used a lot of reclaimed materials, and instead of using concrete, we use wood, the carbon emissions for the house are way lower. So it's that, those kind of decision making that makes your building way much energy efficient. You can go to the next slide.
So I think the first one shows the difference between a plan without vegetation and a plan with vegetation. You can see the ground temperature got so much cooler just with the trees on site. So I think
you need a lot of trees.
Yep.
And a lot of leaves.
And leaves. Trees with no leaves.
We got that critiques at finals. I don't really get why leaves are bad, but people
leaves are
apparently
so
don't like them.
for decomposing things on sites.
Yeah. So that also explains why a lot of cities without trees have heat island effect, where the cities got so much hotter than the suburb with all the concrete and streets without natural vegetation. That's also another aspect of sustainability. We look at CFDs to, well, computer fluid dynamic to understand winds. So this is basically what we're trying to understand, is how wind will travel on our site, so we can orientate our buildings towards it, and maximize natural ventilation. Oh, a lot of rainbow chart. Mika, do you want to talk about this?
Yeah, so what we also looked at were, these are also CFDs within the building, within the house, because we wanted to see how the wind would be moving throughout the house. We tried to create a stack effect so that wind, like the hotter air would move through with the wind to the top of the house. So these are CFD analysis that we did to try to see if what we wanted to happen was really happening within the house. We also tried to heat the lowest floor of the house to create that wind movement upwards, because hot wind, technically it rises. So what we tried to do was like to induce that movement from the bottom to the top. Yes. And I think we were able to do that with some of the, we tried testing out where the heating element should be, if it should be at the bottom, if it should be in the middle. And I think it confirmed our hypothesis that it should be at the bottom to create like the most wind or stack effect.
And then we did the energy simulation, so how much energy consumption our house has. On Houston and Buffalo, and then summer and winter, which is the most drastic climate change. I mean, not climate change, temperature change on the cities that we were analyzing it. So we got not such a good number here, right, Mika?
I think it was oh well, not that good for like a really, really small house.
Yeah. We never understood why, but what's a good number? Is it like, it's supposed to be the lowest number that you get? You see that 33? You're supposed to reach, a net zero building is supposed to be 0, which doesn't exist. It's like zero waste doesn't exist. Net zero doesn't exist.
Technically, like I think you get net zero from, like, let's say if you have renewables, so it's like you're creating energy to offset the energy that you're using. So then it becomes like a net zero building, which we tried to look at. Remember, like we were thinking about putting solar panels as well on top. So
yeah,
we tried to do a lot of things.
Yeah, I remember the discussion of solar panel, but I think the key point here is about we try to achieve a lower energy consumption by the building design itself. So I think one of the reasons the UI might be higher because we pack a lot of things into a smaller footprint. And EUI is a calculation based on square footage. So if we have a bigger house with the same functions and everything, the compliance, because human produce heat too, it will achieve a smaller UI because the square footage per is bigger. So the square footage is bigger, so you have a bigger thing to divide it by. So I think that might be a factor. So next thing, we actually built a tiny thing.
A model.
we built a prototype to test it.
Tiny. It was like we could fit inside.
Yeah, it's like our height, but it's still like smaller than the house itself, but we insulate it properly and try to use thermal camera to understand heat going inside, and we also have a couple sensor inside this model to understand the behavior. You can see the sensor, it has a different color in this photo. So it was freezing cold when we test this model outside. So the I think this is comparing a water roof versus a green vegetated roof on top of the building. So you can see how the soil in the vegetated roof actually keep the roof a lot cooler when it's hot outside. We blasted a heat lamp to the model to try to simulate summertime, and it's really fulfilling to see the result clearly in the physical world, so we can trust our result instead of putting our faith into computer simulation and trust that the math behind it is correct. So we have also do some water testing.
Yeah, so basically,
Yeah.
like, since we wanted a house that was that could sustain itself, like we wanted the house to be able to filter water. So we also looked at possibly filtering the water on one of the walls of the houses.
So this analysis was very eye-opening for me because, I mean, we take for granted rain, but rainwater is way better than our drinking water. And we tested a lot of different things, and we found like lead on the water where we collected the samples. Not now, let me clear that it was under the EPA standards, but it's still lead on your water, as if you were using rain, which is like the purest form. We got some bacteria on the rain one, right? I think, but we were able to remove that with our system. So the question now is, why are we not using rainwater? And I understand here in El Paso it doesn't rain much, so it's not a very efficient system. But in the Houston area, it rains quite a while. So I mean, quite a lot. So why not start collecting this water and store it and use it? Why do we just like let it run?
Yeah. And the weirdest thing is that sometimes rain overwhelms cities' sewage system because people separate them.
Like Philadelphia, we found that there's a percentage of lead in the water, tap water. Why not use the rainwater when it rains so much? Like,
yeah.
So interesting results in here.
Yeah. Okay. Well, I guess this is a little out of order, but these are the chart of temperature we found inside our physical models. So Evan, who spoke last week, actually helped us build that heat chamber. That's a big square that's pretty tall, and we can fit our entire model inside it and plant several sensors inside. I feel like these charts are pretty boring, and next time I'm gonna find a better way to visualize those data, but basically it's finding out the effectiveness of our cooling and heating measured inside. I don't really remember them all, but
yeah, it's okay.
But a very obvious thing here is the regular roof and a green roof. So you can see how the temperatures stay so much cooler inside for a green roof versus a regular roof. And it just keep going in a cold winter, which we have the perfect testing environment on the exterior of Philadelphia. And our radiant heating device actually works okay. You can see the two red lines go above the temperature outside pretty regularly after a long period of time. Because of our insulation is effective, that it's able to keep those heat interior. Okay, yeah, I think that's everything.
Oh, we need to show the house. Do you have the renderings?
Oh, yeah, I probably don't have the
Because you
rendering.
haven't seen the final product.
Yeah, unfortunately, I don't have that.
I think it's in
It's
there.
probably the closest thing.
Let me see. I might be able to share it. Give me 1 second.
Yeah. Before Mika's joining, I actually tell Maria that I feel like three of us are a very balanced team. I feel like I went on the sort of engineering side of architecture, pursuing the technical thing, like what I did in the studio, because that was sort of my role of saying that no, it doesn't work. But I just want to know what do you think about it, Mika, about do you think your career path right now has something to relate to our studio and things like that?
For sure. I mean, like all the things that we've learned in studio, I'm using it today. Like it's like a lot of the things that I'm doing now, it's taking like analyzing the climate and then coming up with possible strategies that we could use in the building so that it's more comfortable inside, so that there's less energy that's used, so that we minimize carbon. It's actually like our whole studio project, but like it happened so quickly because like now like it's needed like right away, like, oh, we have to analyze this so that before people really like concretize the design, like we're able to make a difference with what is being designed. Like, should it have fins? Should the windows be, I don't know, like
Big or
like should it be SNX 51, or like what visibility should it have so that there's more daylighting coming in, because with more daylighting you also have less lighting load on the building. So there's like so many things that are like they're all sort of playing a role together, like so many factors to consider, which yeah, which is like something that like we did in our studio project. We felt like it was so much, but in reality, like that's really how it is. Like there's so much that affects like one structure. Like there's so much that you could think about, there's so much that you can do to help it become a better building and like overall like more efficient building. So yeah, it's definitely like something that studio helped me with. So
understand, prepare.
It's funny because I think what you just said is like very true. I think a lot of people have this conception that when it comes to architecture, it's just like, oh yeah, let me draw something really quick. But after seeing this project, oh
yeah,
my god, like
there's
there's
so much
so many
thought,
things.
right?
And
There's
it's
so
Yes, I'm
much
like,
thought that goes into
it's just a tiny house.
and it's blowing my mind because I would have never expected, like, in order to accomplish this type of things, that so much would have had to like be taken in account. I feel like just one small little detail would have like made everything go to like, "Hoop, no." So my god, like I applaud you for all the work, which seems to be a lot.
It was a lot.
I know who is going to design our installations, like COEX installation. It's going to be all three of you.
I already told Mika, and I just told Shibis.
Yeah, no, you guys have to help us out because we want to be as sustainable as possible, no matter the cost and no matter the time it's gonna take to do that. So I'm mind blown right now.
Yeah, let's talk about that later.
You just need to get the money, and that's it.
Yes. Just wait for us for just a bit, and we'll accomplish it.
Yeah.
And if you take the same approach we did, like use some reclaim material, go visit some dump site and
Yeah.
see what's available on
A lot.
the reclaim market already, and those can save you a lot of money as well as energy.
So just Bombitas, because I know you're visual like us. I have
Yes.
these are the renderings of how the house looks like. It actually is missing piles because these are not like placed on the floor. It's elevated.
Oh, okay,
But
okay,
we didn't
okay.
have time to change that, and nobody really paid attention to it. But these windows right here are part of a system that drains air out. So
Yeah.
warm. Everything in this house has a reason to it. These doors right here are actually kind of like windows that you click in and click out in case you have to attach another house next to it. You don't have to demolish the house. You just you just click in and click out the window unit and then connect it. This is
That's
supposed to
awesome.
represent your water tank. This right here.
Yeah, and we wanted it to
Oh.
be visual because we wanted people to see
That
like
it's
this
a
is how
water.
much.
And then
Okay, okay.
these materials were supposed to be reclaimed from other buildings and other places. I love that Mika did worked on the rendering edits, and she incorporated inclusion and diversity into our project.
Of course, that's part of it.
That's part of it. It's huge.
Designing for everyone.
Exactly. This element here is to mitigate hurricane impacts, to close off the windows so that when it's a hurricane and it hits, it doesn't break the windows. So this is the water tank, this is the connector. So every small decision, like this house is it was like a lot of decisions for a tiny house. And then this is how the houses work at a community scale, like all the houses together, and then how the vegetation is covering the house so that the radiation like from the sun, it's mitigated at a tree level and not at the house, so that it doesn't heat up the house and you don't have to use so much energy. So yeah, I'm gonna stop sharing because then we'll continue to talk forever about this. But yeah, it was a very fun project to work, and a lot of I enjoyed working with Mika and Shibei a lot because we all had so many different ideas and we were
Opinions.
able to execute them very efficiently, I think.
Yeah,
So,
it seems like you guys like just really complimented each other. Even if like before our conversation prior to this, it seems like everyone has its forte, and that way you all got to get in
yeah.
together and make this work, because man, was it work. I'm still mind blown. I'm so
We
sorry.
didn't realize how much work we did until the end.
Yeah.
Yeah.
Until we presented, actually. And we finished early too. It wasn't like we did an all-nighter. So
if the younger generations are thinking, okay, what do I want to do with my life? Why would you, any of you, or if you can all like kind of share, why would you think this is going to be one of the most rewarding careers that can actually like come into? Because I mean, seeing the amount of work, how do you think that's going to impact in someone's lives, or why would you kind of push for them to go for something like this?
I actually think like with Maria, she mentioned like there are like 7 billion people and they all live in buildings. I feel like you can't do away with structures. Like people are always gonna have to live or work somewhere. So if it's something you can't do without, like why not do something good with it? So I think like in my own way, like I'm doing good for I don't know the rest of humanity or the like for the earth. I'm like in a way I'm trying to make um something better, like something that like I said, like you're always gonna have to have a home or have a workspace. So why not create one that's comfortable for you, or why not create one that doesn't destroy its surroundings.
Mhm.
So for me, that's what makes it more fulfilling.
Mhm. Shibi?
That's a difficult question. I feel like Mika said very well. But because I'm not a homeowner right now, but for something like this, I would like to own because it has a small footprint. I can bring it if I move.
Mhm.
I personally moved 3 places in 4 years from,
Mhm.
from
Okay.
different cities. From the I went to school in West Coast and then I moved here to Philadelphia. So I feel like there is a culture in the United States that people tends to move from state to state, and having a piece of real estate that you can bring with you, and it also had a very small impact on the environment. You don't rely on the grid, on your water supply, electricity supplies. It's very compelling to that kind of lifestyle. I feel like
Mhm.
Evan would probably agree if he talks about off-grid living. And he was our TA for this project, for those of you who are interested in knowing that kind of relationship. So there's this notion that the younger generation are more open-minded to those concepts of a mobile living style and more environmental friendly living style.
I
We
am
don't need a 5-bedroom house anymore.
I am gonna add to whatever Mika and Shibei said. The fact that in the U.S. a lot of people live in mobile homes, especially low-income families.
Mhm.
This is a serious problem because where they're currently living at, I mean, not only their infrastructure is poor. Remember when we talked to Allison, our water professor? She gave us, I don't remember if it was an article or a report or something saying that mobile parks,
Water inequity, yeah.
water inequities, social inequities. So if we were able to provide this type of housing for low income communities, we would have also a big impact on them. And it's a form of social justice and environmental justice, providing adequate housing for those who cannot afford to live in houses, in big
Mhm.
houses that have big systems. And I think it is a form of adapting to the present needs, not even the future. Like we're currently making a lot of lifestyle changes. So part of the lifestyle changes that you make is where you live. And that's probably the place where you can have all the power that you want to do change. Like you cannot change others, but you can change yourself and the way you're living and where you're living at. So that's why this is important, because if you provide options for people, then eventually we'll educate through the way that we live. So hopefully this is like something that happens in the near future.
Mhm. And I love that I mean, because you and I were like, oh, well, we might not have kids and stuff like that, but you're still giving that opportunity for those that will have a bigger family to be able to do that. Like you have this small structure, and then if you want to, you can connect several of them. So I think that's a great opportunity for not just people that think like us, but like also those that would be able to have that family, like nuclear family that they really want. So I mean, again, I'm still mind blown. And I think a lot of people should go and study what you did. I mean, you went for your second like master's, Bombitas Maria, however you want to call her. And I mean, I've always like been very surprised by a lot of the things that you have told me, but I had never thought that it had to go so much into that. So kudos to all of 3 of you, because it is a lot of work, and hopefully this kind of just like inspires a lot of other people to go ahead and do bigger things just like you guys are doing. Just not.
And
I'll keep recycling.
female
What?
designers right here.
Yes, I love that too.
Well, thank you so much, Shivis and Miki, for being
Thanks for having us.
No, thank you for your time. Maybe we can have you back so you can tell us a little bit more about your jobs, and we would love to hear about that, obviously, because I know, again, you both are doing such different things at the moment that we'd love to learn a little bit more about that as well.
Yeah, that would be another fun conversation.
Very fun.
Project was like the roots of our careers.
Yeah.
Well, thank you so much.
Thank you,
You too,
guys.